Hello again. I've actually gotten quite far, which is very nice. You can see I added another file called Emitter, so I can already emit assembly code. So this is the output from my program. I can just show you what it's passing. It's this. So we make a function. Inside this function there are a couple of variables, so variable 1, variable 2, and then I'm going to assign into variable 1 again. So the first one is just a binary operation, 2 plus 3. Next one is 4 plus 9 and 1 plus 1. And then we have another function with some other variables, and then enough pass. So if we look here, if you know anything about assembly, you know that you store your variables on the stack. So currently I've made a simple table. However, the way so I have a little bug right now, because there's only actually 2 variables in this, var1 and var2, but it counts var1 as another variable, and that's because I'm using the descriptor for this token as kind of like a hash map. So I take the descriptor and then I look into a table, and then so this token is actually different from this because its descriptor is different. I can just show you how it looks. So this is my token buffer. So first there's a main, this one, then there's var1, and that's followed by var2, and that is followed by var1 again, as you can see. And then we have another func, and then we have seal, sd, sdfg, and that's it. So that is the tokens I have. So the descriptor for main is 0. The descriptor for var1 is like 5 or something, and then the next one. And because I'm using the descriptor, which is basically the offset into this buffer, as like a value to look inside my simple table, you can see this is actually different from this because it has a much bigger offset. I need to figure out how to fix that. It shouldn't be that difficult, but I just need to think about it. What's going on here? Nice. Okay, so the program has, let me just remove this. So we have main. We make room for the 2 variables, which is 8 bytes each, so it's 64 bits. So basically not an integer but a long in some languages. So anyways, I'm doing a stack machine. What is going on here? Okay. For some reason it's pushing a 0. That's weird. It shouldn't be doing that. Anyway, we push the first of the binary operation onto the stack, and then we push the 3, which is the next one, and then we pop them into registers, and then we add them together and push them on a stack. This way this is basically what it's called, a stack machine. It's a simple way to make your virtual machine. So just always have the latest value on top of the stack. So if you need to use it afterwards, you can just pop it. And we can see we want to do the addition 2 plus 3. So that is what we're doing here. It should be a 2 here. I don't know why it's a 0. But pop, add them together, then push it to the stack. Now we need to assign it. So we pop the value that we did, and then we move it into the correct spot on the stack. And then we do the next, which is 4 plus 9. Pop, add, push. Then we come to the assignment part, pop it into the racks, and then we push it into its spot. And then we do some shorthand, leave and return, which is basically the reverse of this. And it also works with another func. We can see here the actual offsets are not like they are unique to the function itself. So this has 2 variables, and we can see this has 3 variables. Yeah. So how did I do this? I have just made a whole bunch of hard-coded strings. That's the easiest way. So emit, and then assembly, and then the prologue, and that is basically the header for any assembly file. So you can see here .section.text, which basically says that what comes after here is code, and then we do a .global and start, which is basically the main entry point for any function. So kind of like in C, the entry point is main. In assembly, it's underscore start, and you have to make it global, otherwise it's the compiler cannot find it, the assembler cannot find it, the symbol. Yeah, so I just have hard-coded them all. Boom. And then in the emitter, you can see here, I have a lot of just emit add, okay. Move into racks, it's write to standard hour, load the address of this, and then I say it's 7 long. 1, 2, 3, 4, 5, 6, 7, and then we just do a syscall, and then it prints it out, and then we can leave and return. Yeah, so it basically just goes through here. I know that any function or any program is just always going to start with a statement. A statement can be a function declaration, or it could just be 2 plus 2. That's an expression, that's not a statement, but an assignment, for example. So we visit the statement because that's the first one, and then we just compare what is the ID of what we got. Is it an assignment? Is it a statement list? Or is it just a function? If it's an assignment, we jump to a part called assignment. If it's a statement list, then we jump to the part of the statement list. If it's a function, we jump to the function. Otherwise, I haven't implemented everything yet, so we just return. So in our example, we start out with a function. This is a statement until here. Oh, actually, we start out with a statement list because we have the first statement, which is this, and then we have the next statement, which is this. So we go to statement list, and then we retrieve the statement list. We see here, this is the left-hand side, and then we just call visit statement on it. So we recursively call ourselves. And then we see, okay, it's actually an assignment, or it's a function, because this is the first one, so we jump to the function. And then we have to tell our program that we are actually in this function now, and that has something to do with the simple collector, the simple table. Then we just get the function, emit a new line, we emit the identifier and the colon, which is this. And then we emit the function prolog, which is this part. Then we need to emit make room for local variables. So we emit a subtraction and then the dollar. And then we need to calculate this. So we find the count. It comes from this function, retrieve function. I can just show you. A function has a identifier, the name of it. It has a type, like what is the body type, and it has a body. And then it has a number of variables, which is basically what we want. So that is this part. And then we just have to multiply it by 8. That's what we're doing here. And then we emit the number. And emitting a number is actually kind of difficult. Oh. What is going on here? Here. Yeah, as you can see, it's kind of... You take in a number, and then you have to figure out how long it is, and then you have to convert each of the numbers into... you need to convert each of the digits in a number into the ASCII representation. So these... if I can see here. Okay, so we basically divide the input number with 10. You can see here 10. And then we get the remainder in RDX, which we can add 48 to, and then we get the actual ASCII character. So if we have a 0, where is it? Here. If we have a 0, then we add 48 to it, and then we get 0. If we have 2, we add 48, then we have a 2, ASCII character 2. So that's basically what we do. And I'm using the stack as a char pointer, basically. So we just push everything to the stack. However, you can only push 64 bits at a time if you use x86 64-bit Linux, for example, as I am. So you have to do some trickery where you actually manually offset into the stack pointer and then move the stuff. However, this can be kind of bad because we can accidentally offset our stack. So we have to ensure that we are not offset, because you always want to be aligned 64 bits. Otherwise your program kind of it will start acting weird because it doesn't know where it is anymore, or it doesn't know. All the values will be fucked up, basically. Yeah, this is here. I ensure the correct alignment. Basically, I just round up to the nearest 32-bit or 64, it should actually be. Anyways, so that's the push or the print number. Yeah. And after we have printed the prolog, this part, you can just call yourself again, visit statement, which goes up here, and now we know it's a statement list because we have 2. And so we go to that part, we jump to that, and then we just retrieve the statement, check, visit each statement, the left hand side and then the right hand side, and that's it. So recursion is very nice. If we reach an assignment, let's see, this is this. We basically just retrieve the assignment. I have some buffers for it. a function buffer, I have a stable list buffer, an assignment buffer, binary operation buffer. So I store everything kind of globally in a global bunch of arrays. Currently 256 bytes. This is going to be increased, of course, but just while I develop, this is a very nice number. It's basically 64 integers. Yep. Anyway, then we can just call visit the expression. And then you can just emit a new line, pop. Yeah. It's basically kind of straightforward. You just have to mimic what like boop 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 boop, one by one. The expression, there's basically two kind of possibilities. You can either have a binary operation or you can have a number. If it was neither, then I don't know what it is, and I have no idea. What can it be? Expression. It could be an identifier. Yeah, I haven't actually implemented that yet, but it could be an identifier or a function call. Yeah, so I can implement this here. If it's just a number, then we can just call a push and the $, which is this. And then we have to retrieve the number. And remember, all my numbers and all my stuff is in these arrays. However, numbers are actually stored in the lexer. So if you find that here, you can see I have a where is my oh, it's in the utils. Ah, nice. Yeah. And that is actually not here either. Where is it then? Oh, it's in the config. Nice. I have them. Okay, I should maybe put them together somewhere. Yeah, I don't know. Yeah, so everything is arrays, and then you have descriptors, and then you can ask the compiler, where is it? What is the value associated with this descriptor? So that's basically what we do every time. And then we can emit the number and then a new line and leave. If it's a binary operation, then you have to retrieve the binary operation, and then you can call yourself again on the left hand side and then on the right hand side, and then you just have to emit some pops and find the operator, and then you just have to insert the correct operator. Currently I only have add and subtraction, and these are down here. So emit and add rex comma rbx, which is add rex rbx, and then the next is then a push, because then we have the result in rbx. So this is this, and then you just add a new line for pretty sake. And the same thing is with the subtraction. You just emit a sub instead. And that's kind of it, like how you emit stuff. It's kind of easy, very nice. I think I will talk about this in another video, because this is kind of hardcore. It's very difficult. It's not difficult, I just had some troubles with it. Yeah, so I think I will explain it in another video. Yeah, let me do that.